All right, I have started the record. So then let me share my screen. All right, I guess you can see. That's great. So what will be your second task? Your tasks will be about tendon systems. This task will be related only for passive models without any driven systems. So you'll have only to make a simulation model on passive system. Description of elaborated description of tendon systems is in MuJoCo documentation in XML reference about tendons that tendons are subset of attributes of special tendons. Oh, sorry. I mean, tendons is wires which can be used to impose length limits, simulate spring and damping, and drive friction forces, as well as attach actuators to them. So, in other words, you can use tendons for systems not only for passive mechanical systems with elastic modeling, but also as driven systems where drives attached to some kind of tendon which moves a mechanism. In this example, I will show you a bit later. The passive actuator here, in quote unquote, is just the gravity, which implied to this blue mass system. So I have written a very brief script, just importing MuJoCo and running the script, and I have prepared some interesting models to demonstrate you. So let's start from first one, ARM26. So do you see the simulation model here? It's okay? Can you see the screen?
Yes.
Okay, that's great. So what you can see in this model, this small diameter wires are tendons. They simulate the wires in real world. And as you can see here, they impose some kind of elasticity. So as you can see, this some kind of elongation creates this elastic movement. So this simple two rotational passive mechanism with this elastic body. Oh, sorry, with this elastic tendons. Another example, Newton cradle. Very simple and yet beautiful example of this. So let's prolong it a bit more. So these blue tendons, they connect these yellow spheres and they impose length limits. So they make this holonomic constraints. Because of them, these yellow spheres cannot move downwards. They can just rotate around these links. But in comparison with rigid links, tendons can bend, and thus the movement is a lot more rich, which can be used for specific applications. Another idea of this is this system. Giant sphere with lots of small balls attached to tendons. For each of these gray wires are tendons. And for example, I can move this giant blue sphere, and you can see it models it in real time. It is not pre-rendered. It just simulates right now. And actually, this is quite astonishing because this is simulated in real time, and other simulators, for example, MATLAB cannot do that. Maybe there might be specific toolboxes and libraries to model tendons in MATLAB, but I bet they are a lot slower than in MuJoCo. So, and you can see it models it in quite high FPS. So very, very great thing for simulating tendon systems. Another tendon system is, let me show you example with elasticity of the tendons. So I copied this XML file from internet just to show you the comparison between these tendons, how can they behave. So as you can see, they can bend, they can stretch, and they impose these holonomic constraints like here. And last but not least, the example from official MuJoCo documentation is this to free rotational finger with this gravity mass, which is imposing this passive force. And as you can see, these tendons, they stretch. Let me slow it a bit. So as you can see, they stretch and they imply this the stiffness of the tendons. And your task is do something similar to this system with tendons and just run it and look how it behaves. Just to practice yourself for the XML redacting. So these are simulation models. Maybe also this. I have shown this here. Yeah. So what's the task?
Uh,
Yeah,
I have a question.
yeah.
So, is it possible to control the kind of force along this one tendon? Like force, I mean, with that I mean kind of shear strain or tension in a tendon in a particular tendon.
Yes, you can control
Is it
tension.
possible to control it?
Yeah,
Yeah. Is it
it is
possible?
po yes, that's possible. And let's return to this example. Instead of just gravity, you can make a specific mechanism with a motor, and you can drive this tendon and move this finger with motors. So you can use the tension to make the movements of the finger.
So suppose we want to control the second tendon from the top on the right side from the top. I want to control it. Is it possible to control it using, I mean, in the simulation? Like I ask this because this system is passive one.
Yes, it can be controlled by simplicity sakes. This task will touch only passive system with standards, but it can be articulated via motors, like
Oh,
in
cool.
real life applications where a pulley coils the wire and it creates the tension, hence makes the movement of the complicated tendon-driven mechanism.
So one more question. It would be a stupid one, but I have a question. Like, why would we use tendon along with the motor?
Mhm. Instead of what?
Uh, Along with the motor, like motor can control the joint, but I mean, why would we use tendon along with the motor?
You're asking this question why we generally use tendons or specifically for XML model?
Why? In general.
In general, the answer is pretty simple. Look at your hand. and try to move your fingers. As you can
Mm-hmm.
see, muscles which moves your fingers are
Mm-hmm.
placed not on your palm, not on your phalanxes, but it's hidden in your arm before the palm. What's the idea of that? Why evolution have made this? Our hand has these tendons which actuates fingers by the muscle hidden in the arm. And this makes our arm, our end effector, smaller because muscles have some kind of volume. And if evolution have placed the muscles in the phalanxes directly, the hand will be extremely large, bulky, and quite very
So can't we
hard to control.
can't we
So
just use can't we just use a very small motor? I mean,
the idea is here is that even if you use small motors in some kind of robotic arm or leg or something like that, it increases
mhm.
the moving moving mechanism, inertia, and mass. And since inertia is high, it increases energy. It increases requirements for motors which should need the arm. For example, for the mechanism of the arm, it's okay, the motors can be placed directly, but motors which move the arm with all these motors placed should be quite powerful, and it increases the sizes of the mechanism, it increases its mass, inertia, and the idea of using of tendon systems is to
But
place motors in some kind of static body and put all these lightweight wires to the mechanism. And the mechanism will be very small and
okay,
precise.
okay. Mhm.
Another example of this is Da Vinci arm. Yeah, surgical arm. For example, this arm uses tendon-driven systems, and these surgery
Okay.
operations must be provided with very high. When robots when surgeons make operation on human body, the operation space is very small. For example, you need to cut some kind of organ on human body, and if you use very bulky and big arm, it will be impossible to go into some kind of specific small spaces in the body of human.
So we
So we place
okay.
motors
So
outside the end
we
effectors. Yeah,
okay, yeah. Mhm.
yeah, got
Okay,
the
okay,
idea.
cool.
So we
So this
place.
this was the point I was just
Yeah. That's the idea. We place the motors outside the end effector, and thus the end effector itself becomes a lot smaller and lighter and less dangerous. For example, for interaction with human. So that's the idea of tendon systems because they bend, they stretch, they make able to place motors further away from end effector and so on and so forth. They also can be used for legs.
so is there
Uh,
any
what?
so is there any disadvantage is there any disadvantage of this setup removing motor from the main system and
Yeah.
to make it lighter?
Some series of advantages and disadvantages. Advantage, as I said, it moves away the motor, makes the end effector smaller, decreases its mass and inertia, makes it move in smaller envelopes. But the disadvantage is that, of course, the mechanism is quite complicated. The designs of these tendon-driven systems are quite tricky. For example, um, let's let us look at some examples here. So, like I don't know, like this. So mechanism is quite tricky and very complicated. But they make us able, as this example, this is some kind of leg This makes us able to place all the motors not in the hip and knee, but place it on the static body, and the leg will be very small and light. But the problem is that the design is kind of complicated, and we need to know specific techniques how to synthesize these mechanisms. So that's the main key things about tendon systems. Have I answered your question, or you want to clarify something a bit more?
No, 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 no. It was. It has.
Okay,
It has. It has.
okay. I ask you a
Thank you.
question. It's okay. Okay, you're welcome. So the idea is that tendons are cool and great, and we can simulate them using MuJoCo. So that's the idea of using them. And hence the tasks, the second task for our subject will be the following. We have two rotational passive mechanical systems. So we have static body, rotational link, sorry, rotational joint, link, rotational joint, and another link. At the joints, we have pulleys which have some kind of radius R1 and R2, and we put these two tendons colored in red and green respectively, put in the tendons in this pattern. So we put the tendon upper the pulley and then down the second pulley, and vice versa for the second tendon. And the idea of this is, first of all, study examples of tendons usage in other XML files, which I have shown you, and I will provide you in the Google Disk if you're interested. You can also Google lots of examples with tendon systems in MuJoCo exist. Then compose simple two rotational mechanisms, firstly without tendons, then add two tendons thrown over pulleys. So you do this step by step to increase difficulty, and analyze the motion of the passive system. The system shouldn't have any motors yet because you need to practice yourself with XML modifications by adding elasticity to the tendons. So as I shown you, the tendons have elasticity, and you can program them. You can program elasticity and damping to the tendons, and the idea is to make them elastic, so they should some kind of bend and stretch. And at the rides, some kind of sketches how it might behave. So two rotational passive systems with pulleys and tendons thrown over these pulleys, and idea is to model the XML file of this finger, of two air finger, and look how it moves passively. So for more details, you can see at XML reference, there are a lot of description about tendons, how do they behave, and all the stuff. And that's it for this question. For the task, I will give you a table with this lengths A, B, C, R1, and R2, and then you can begin doing the task. So, do you have any questions about this or something
Yeah.
else?
The two
Mhm.
pulleys
Mhm.
that are with radius R1 and R2 move freely, like without any constraints.
What do you mean moving without any constraints? Pulleys are
Like
like what? So continue your question, like what?
I mean, just pulley.
I mean, pulley, for example, in this example, colored in green, they rotate. I mean, they placed in the joint. So if I show the joints are these blue cones. Pulleys are placed with joints together. So they constrained to be placed in the same spot as the rotational joint. So you got the idea?
Yeah, yeah, yeah. Just it moves.
Mhm.
I mean, it moves freely.
Yeah, it moves freely, but together with rotational joint. So it will rotate with these
Okay.
joints, but they impose constraints for the pulleys because if this pulleys will be will have zero radius, then the pulley will just fall off and doesn't apply any constraint to the system. So that's the idea. Other questions? All right. Let's say that now you do not have any questions because you need to work with this. I will update the information about the task right now after today's meeting in the folder. I have pre-made this task 2 folder, and I will load the PDF file with the task files in XML where you have take some inspiration, and values of ABC R1 and R2 where you can model the system. So actually for today, that's all. Today was very brief meeting, and as a reminder, I think each Saturday, like today, we will gather for like half an hour and discuss next tasks. At the next week, at 16th of November, I will give you the third task, and 23rd of November, I will give you the fourth task. And that's about it. And at these meetings, we can also discuss not only the task, we can also discuss some of the questions about the tasks online, or your projects ideas or your projects themselves, if you have started doing them. And if you communicate with me outside this days, you can write me in Telegram or by my email, and we can discuss personally. So I guess that's about it for today. Maybe you have some final questions, and if you don't, we can go.
All right,
Thank you.
sir.
Bye.
I have a
Mhm.
question.
Yep. Good question.
Okay, are we simulating the motion of the toe, the finger, using a Python script, or is just the normal MuJoCo effect that should be on it? Are we simulating it with a script?
Yeah, what's the intuition of this? Let me show it again. Intuition of this is the following. MuJoCo is simulation system which runs the scripts written in XML. XML is this text. XML by XML you create bodies, the childs, and connect these bodies with links and create the simulation model. So firstly, you write the XML file and execute it from MuJoCo. For example, here I have made file tandem.xml and run it, and for following number of steps, and in this cycle I model each step and look at the simulation model. So, and that's how it works. Have you got the answer, or maybe I need to ask
I
something?
think I think there is a another way they do run the motion effect with a script, with a Python script like that. And so I was asking whether in this task we are going to use another script to support the XML script to give us the rotational effect.
You mean the rendering of the simulation model?
No, I think MuJoCo Viewer automatically does the rendering.
Mhm.
So,
So
okay,
didn't get
I think
the question completely. Could you clarify a bit?
maybe I will just type it and send it to the group.
Okay. Maybe we can communicate by text. Maybe I didn't understand the question correctly.
All right.
Mhm. Okay. Okay, then we can go, and good luck. Bye bye.